This is the Smart Buildings Academy podcast with Phil Zito, episode 461. Hey, folks, Phil Zito here, and welcome to episode 461 of the Smart Buildings Academy podcast. In this episode, we are going to be going and diving into building automation inputs. My background might look a little different because I'm literally shoved in the corner of my office. Our air conditioning is out in our house. So the only place that has air conditioning conveniently is my office with a mini split. So yeah, this is where I'll be recording from for the next couple episodes until we get a new air conditioning unit put in. Wonderful times in Northern Arizona. That being said, everything's going to be available at episode 461. Or sorry, can you tell it's been a while since I've done this? It's going to be available at podcast.smartbuildingsacademy.com/461. Once again, that's podcast.smartbuildingsacademy.com/461. So you'll see it probably about 3 to 4 hours after this initial live stream. Just want to make sure everything is working well because I haven't done a live stream in a while and it looks like everything is. So here's what's going to happen today. We are going to be going into outputs. In the previous episode, we started on this kind of creating a series of episodes that would help people who are brand new to the industry. Really wanted to get people up to speed. And we're going to be continuing on with that series now that my whole schedule's kind of slowed down a little bit. I could get back at things. We're going to be talking about outputs today. So you're going to learn what outputs are. We're going to go over the most common outputs, spend a little bit of time on that. I'll catch you all up with what's going on in the business, kind of new things there, and then take any questions you have. So it's good to see you all again. Let's dive into outputs. So today's objectives of this podcast are going to be talking about the relationship between an input, a process, and an output. So you know inputs from the previous episode if you watched 460. Now we're going to talk about outputs, and we'll talk about kind of processes. Talk about states, then we'll talk about different types of outputs. We'll provide an example of each, and then we'll talk about binary outputs versus analog outputs. By the end of this, you should have a pretty solid understanding of what outputs are in the frame of building automation. So thank you to Joe on my team for putting this PowerPoint together. This is a abbreviated version of one of the lessons in our courses. So that's what I'm going to be taking you through here. But building automation systems, they follow this kind of input, process, output, action. What does this mean? You take in some form of data, whether it's a physical input or it's a set point, some sort of logical command. So you can have physical command or physical input data or logical input data. Then some form of logic happens. This is usually in the programming, although in the case of like schedules, other things like that, it can be something that's preset and happens automatically. And the input could simply be time going into a schedule block and saying, hey, it's 8 a.m. It's time to turn on occupancy. And so then the output could be occupancy and the action would be all of the boxes going occupied. Well, this actually can remain the same. And what's really cool about this, I'm going to segue just a little brief moment here. What's really cool about this, if you understand these 4 steps, input, logic, output, action, then you can actually apply this to access control, to lighting, to fire alarm, any of the building technologies that you'd commonly, AV, audiovisual, because at the end of the day, you have a card swipe on a badge, on a card reader. That's an input. It compares the data on that card to some sort of database, depends on what access control system you have. And then drives a lock, drives a magnetic lock to, retract or unlock or whatever. So that signal gets sent out and then the action is it unlocks. That's the same with building automation. And as you'll see in the next slide, that's the same with life. So you grab the handle of a skillet or cast iron if you're like me and you like to cook with cast iron. You grab the handle and you're like, crap, this is really hot. This sucks. So your brain decides, hey, I should probably do something about this. You pull your hand away, right? It says pull it away, and then you pull your hand away. Pretty straightforward, pretty basic. But if you understand this input, logic, output, action, and I'm going to pause here to spend a couple seconds on it because where you are going to spend a lot of your time troubleshooting is one of these areas. Either you're getting bad data from the input, the logic is broken, the output isn't working, or the device that the output is controlling is not working. If you follow this, you will be able to troubleshoot almost any building automation system or other control system issue. Either you got bad input, logic's broken, the output's not properly commanding or controlling, or the end device is not properly working. So let's talk about states. This is something that I really like to do. I encourage you, if you're not doing it, that going and programming using state-based control is really something to do. And Joshua, I see you in the chat. Thanks for chatting. Joshua says he agreed that the fundamentals transfer. Most of the differences are in the graphical user interface and where to find what you're looking for in the interface. Absolutely. Yeah, most of the issues you have with learning another system are quite frankly learning the user interface. Most of the fundamentals remain the same. But back to states. So a state simply refers to the mode, position, or condition something is in. Let's talk specifically about mode because this is where I see a lot of people get tripped up. Is you are working on a rooftop unit and you're like, man, why is this rooftop unit blowing cold air, but the air is humid because it's at saturation, right? Well, that's because it's in cooling and not dehumidification mode. So at first glance, you walk up to the unit and you're like, well, I mean, the DX cooling's on, but the gas-fired reheat isn't on, so you're not able to reheat the air and bring it back up from saturation. So you're subcooling the room, causing all sorts of humidity issues. That's why mode is critically important, because if you're at the wrong mode, in the wrong mode, then you're going to drive the wrong outputs. And this is where, not to pick on mechanics, but I see a lot of mechanics get in trouble here is they'll get called out for an issue at a building and they will go to check out the issue. I'm going to take some water. So they'll go to check out this issue. The example I gave was dehumidification. They go and they see that the DX is on, and for whatever reason, they don't check the gas-fired reheat, but they say, oh, well, it looks like it's functioning. It's cooling, and then they don't see the reheat, and so they think everything's well, and they think it's something else. Now, I know you could say, well, obviously that mechanic should know that you need to heat back up the air, because if they understand psychrometrics, then they understand you're going to cool to saturation, and then you're going to be at 100% relative humidity, and you've got to reheat it to bring it to that lower humidity. Yeah, you're absolutely right. But sometimes when it's the end of the day or you're on your third call, you don't think of these things. So a simpler thing would be to check what mode the unit was in. What is it being commanded to do? Is it being commanded to dehumidify, or is it being commanded to cool? I'm sorry, it's really cold in my office, which makes, speaking of humidity, actually in Arizona, it dries out the air, because then it gets hot in my room again, and then the air gets dry, and I have almost no humidity in here, so it sucks. And it makes me cough. But like I was saying, going back to mode, this is an area where you really have to understand what mode you're in, because just how a system is displaying itself may not necessarily be representative of what it's meant to do, and vice versa. So, you've got a system maybe in heat mode, and you've got zone temperature sensor. It's telling the controller the space is warm, and the signal may change from heat to cool mode. That's called a change of state. But it may actually close the hot water valve to a heating coil. And this is why it's not only important to understand the mode, but it's also important to understand that process loop right here. Because here's the deal. If you have on-off heating, maybe you have gas-fired or electric heat, when it gets too hot in the space, you should expect to see a Boolean or a binary output to be commanded off. If you have a hot water valve, or maybe you have steam, you should expect to see an analog signal, which will become really important as we dive into the outputs, which is why you all are here. So let's start looking at it. Got a couple different types of outputs. We've got contacts, on, off, incremental, and voltage. You can argue that we also have amperage as a output type as well. So contact outputs, pretty straightforward. They are a binary output. They're known as dry contacts because they do not normally have voltage going across them, which would then make them wet contacts. What can happen is with these contact inputs, they're normally open, signified right here by NO, or, oh, fuck, I'm not doing my, I cursed. I'm not doing my, you guys got to tell me, I'm not doing my PowerPoint. I haven't done these in a while. So we're oh, welcome back, Phil Zito. You're stuck in a corner and you forget to turn the PowerPoint slide on. All right, here we go. I promise you, there were some great PowerPoint slides that you missed. Input, logic, output, action, right? We went through that. Fortunately, you all didn't miss much in form of PowerPoint slides. Input, logic, output, action, and then states, right? We've got our state. Our state's going to be heating. It's going to be cooling. For those of you listening to the podcast, you didn't miss anything because you're listening and not watching. But let's get into our outputs. Like I said, output type, contact, on, off, incremental, voltage, and potentially amperage. Hit that like button if you like watching me do things live and make mistakes in real time. All right. So in all seriousness, we've got our binary output known as dry contacts, normally open, signified by NO, also signified by two lines and a broken connection, or normally closed as signified by the two lines and the complete connection. Now, the important thing to know here is these are de-energized. Whenever you look at an electrical schematic, it is going to show the de-energized state. So if normally open, when energized, the relay coil should pull this normally open to be normally closed. So the important thing to know is that, as I mentioned, you have these dry contacts here. And these are typically, in most cases in building automation and other scenarios, on the controller side of things, used to simply source the relay voltage through. What do I mean? Or the coil voltage through. So what you would do is you'd have a transformer and it would go through the normally open contacts, go to the relay coil, or the coil of the relay, and then would energize that coil, which would pull in another set of contacts, and then would continue from the coil back to complete the circuit. The reason you would do this is to electrically isolate loads from your controller. Now, some controllers can have loads going through them. Even though you can, doesn't necessarily mean you should. I prefer, quite frankly, to keep my load separated from the controller, especially if it's anything above 24 volts. That way, you don't have to go and be concerned about taking 120 to a screwdriver when you decide to go and work on a controller during a troubleshooting call. Now, as I mentioned, the normally open won't allow power to flow until the controller closes it. So we can kind of see this demonstrated here. And then the normally closed will allow power to flow until the controller opens it. We can see, right, the power is flowing through. Let's keep going. On-off outputs. On-off are binary outputs similar to contact outputs, except for they provide power from the controller. So this would be where you have a direct 24 volts coming out of the controller. Often triacs do this. And you'll have this 24 volts going to the relay, as you can see right here, into the coil. And then that coil will close these normally open contacts. So you can see this is another representation of normally open. It's two lines separated by white space. If these were normally closed, there would be a line kind of not diagonally, what is it? Perpendicular to these lines right here. All right, let's keep going. Incremental outputs, the most common actuator you will see on terminal units. And why is it the most common actuator you will see on terminal units? Because it is significantly less expensive. The reason why is the conversion from a 0 to 10 volt signal to actually drive a motor takes some different chipsets, takes some different devices inside the actuator that cost more to produce. So what you will tend to see on VAV boxes is a floating output, which you'll have a single common, and you will either turn one leg hot or the other leg hot. So you'll have three connections, as we see right here, three terminals. And you will then either drive the clockwise rotation or counterclockwise rotation. These are very common for valve control at terminal units and rooftop units due to the lower price. So basically, you float between the clockwise or the counterclockwise rotation. So they have a shared common, typically use 24 volts AC. And as we'll see, right, you have your common wire, and then you have one wire that will rotate you clockwise, and you have another wire that will rotate you counterclockwise. Pretty straightforward. These are also pretty easy to wire up. And what these tend to use is they use the on-off output here to then drive the incremental output. So you'll have a single common, and then that shared common will pull typically power from BO1 and BO2, and you will set up a incremental or floating logic block inside your building automation system to then drive these accordingly. Voltage outputs. Voltage outputs are analog outputs. These are used proportionally on a predetermined scale. Most commons are 0 to 5, 0 to 10, or 2 to 10. And if we were to put these in milliamp, these would typically be 2 to 10 would be 4 to 20, 0 to 10 would be 0 to 20 milliamps, and 0 to 5 would be 0 to 10 milliamps. So that is what they convert to on the amperage side. You'll use voltage when you typically don't have a long run, you're not dealing with a lot of interference, and you also want to be able to measure these in parallel and not in series. You'll use amperage typically when you have a longer run, more than 200 feet. You have electrical interference like in production rooms, hospitals, etc. And you also want the difficulty of having to either use an amp clamp or measure in series. Now, I'm just joking slightly there for those of you who have had to measure milliamp out in the field and don't like having to either find an amp clamp in your bag or go and actually disconnect the wires. So here's an example. Typically, this will be straight voltage or amperage out of our controller, two-wire connection typically. And this is an example of an ABB speed drive. Those of you who know, you pull this little panel off, and right there will be your input that you will then wire your output into. So your output on ABB will go into inputs. And so you'd wire your 0 to 10 to ABB's drive. And then if you gave 5 volts DC, the drive would know that it should run at 50% either speed or capacity. So in a nutshell, there's not a whole lot of outputs, and they're pretty simple. The big things to know are you've either got analog or binary outputs. Analogs are signals that vary, like 2 to 10, 4 to 20, etc. And binary is something that only has two states. It's either on or off. It can also sometimes be called digital. Now, I do want to go back real quickly, take a look. As we look at our on-off, right, there's only two states. As we look at our contact, there's only two states. As we look at our incremental, there truly is only two states. We have a shared common, and then we either have a state of floating or sorry, a state of clockwise or a state of counterclockwise. You could say that we have a state of off on a 3 position. But really, there is the on-off state for clockwise, and there's the on-off state for counterclockwise. And if both of those are off, obviously the thing's not moving at all. And then you have your voltage outputs. And these are going to be your analog outputs. Okay. So we talked about inputs and outputs. I learned how to share a PowerPoint on a live stream again, which was awesome. I apologize for not sharing it initially. We defined a state. We talked about how it relates to outputs. We listed the 4 different types of outputs, provided an example of each, and we talked about the difference between digital and analog outputs. I'll hang around here, see if you got any questions, any thoughts. I definitely welcome those. It's good to be back. It definitely is. I got to remember to bring more water next time. The joys of living in Arizona. Man, it's like wildfires right now, pollen, and lack of humidity. It's like a trifecta for making it difficult to do podcasts. But, I'm here for you. As always, everything will be available at podcast.smartbuildingsacademy.com/461. Once again, that's podcast.smartbuildingsacademy.com/461. I do want to bring you up to date on a couple things. One, we've got our next cohort of workforce development opening in September. So if you've got new hires that you need to get up to speed, now is the time to sign up. You can find out more info at smartbuildingsacademy.com. That's the program that will give you an 80% job chargeable resource by week 4 of the program. That means someone is literally delivering mail or working as a bartender, and in 4 weeks, they're out on a job site, 80% job chargeable. By week 11, they're able to be in their own truck. We have done 10 cohorts of this now, not including our OEM specific cohorts. Additionally, we're working on a couple really cool things in the training world that I can't announce yet. But I can announce that we have partnered with Cochrane Supply to start bringing training to Cochrane's customer base. So if you work with Cochrane, reach out to your local Cochrane branch. We have partnered with a company called ThinkTech in Australia to bring the first and only self-paced Niagara TCP class, meaning you can go and take the Niagara TCP at your own pace and get TCP certified. So we are now offering that. And we're also going to be announcing in the very near future a couple more OEM specific trainings that I think you all are going to be very excited about. It's great to be back, Andrew. Thank you. It's always this May, June time frame. It gets ahead of me, and then getting the podcast done is just difficult. You know, my daughter graduated 18th, or not 18th birthday, graduated high school. And then my son flew out yesterday to Perler Academy in Missouri to do a 28-day wrestling camp. So he's in a 28-day high school wrestling camp in Moscow Mills, Missouri. So it's just the wife, the kids, or the girls and I. And the wife and I are sleeping on air mattresses in my office because our evaporator coil is leaking refrigerant like crazy. And the way our house is built, you can't repair it because they basically put it in this like recessed area where you have to cut it out. So that's fun. So that should be done next week. And then we'll have air conditioning back. Thank God I put a split unit in my office. Otherwise, I don't know what we would do because Northern Arizona is so freaking hot right now. And for those of you who don't follow me on Facebook or anything, I got a giant garden going in the backyard too. So I've been up to that. That being said, I will see you all, I believe, Friday. And this Friday, I'm not sure what we're going to talk about yet, but it'll be fun. I have a couple ideas. Oh, and we have a bunch of podcast recordings from the Niagara Summit that I'm going to get edited and get those posted. So you should have 4 episodes coming from the Niagara Summit as well. So we'll be getting those up. It's great to have you all here. It's great to be back. I do apologize for the absence. We're trying to get a lot more podcast guests. I've got my marketing guy on that. He's going to be setting up a process. And with that being said, it's fun to see you all again. I hope you all are doing well. And I'll talk to you all on Friday. Take care.